Okay, welcome. So our last session we talked about this table and we talked about when and how to apply which procedure. And that depends very often on the combination of variables that we want to examine. For example, if we have in the first line 2 times nominal scaled variable, an example would be the preferred vacation destination depends on gender. So vacation destination and gender are both nominal scaled variables. Then we have to create a cross table and to apply the chi-square test. So let's do that with our dataset first survey. And here we have the dataset. Let's say we want to examine, is there a relationship between the variable class and the variable work? So our research hypothesis could, for example, be that the proportion of working students in the examined classes is different. Yeah, the null hypothesis then obviously would be there is no difference in the proportion of working students in the examined classes, and we will do that now with a cross table. Therefore, we have to click on Analyze, and under Descriptive Statistics here we find the cross tables. Yeah, we click on cross tables, and now we need to put our two variables class into the rows and work into the columns. Okay, let's go through here. Here statistics. Here we have the chi-square test that we need to apply, and we can also click on phi and Kramer V. That will give us an idea how strong the relationship between the two variables is. And I think that is all. We don't need more. So click on continue. Let's click on cells. Here you can have different options. So usually we have the observed values. These are the absolute values from our data set. The second option, the expected values, is very important because usually SPSS compares the expected values. These would be the values if the null hypothesis is true. So if there is no difference between the classes, how many working or not working students would we then expect in all the classes? Yeah, that are the expected numbers, and we compare the expected numbers with the observed numbers, and from that we calculate the chi-square. Here we also have percentage. Very often it's helpful to show the percentages. So let's just take the percentage. Yeah. In the rows and continue. We don't need format, style and bootstrap, but we want to show a grouped bar chart here. So grouped bar chart, and then we click on OK. So let's have a look at the output. And here you see we still have a problem in our cross table. Yeah, we have German and English speaking students in our survey, so that we have yes and yeses, and we don't want to have that. So therefore we first need to recode this variable. So let's do that, and then we apply the cross table again and also the chi-square test. But you see here already, here we have the absolute numbers, here we have the percentage in the row. That means in the row means that these 100% are all Alba students from the class Alba here. Yeah, and you see 50% of them said yes, and 50% of them 50% said yeah, and 50% said yes. Okay, here you see ESM, 5 students that are 62.5% said no, they don't work alongside their studies, and 3 work alongside their studies. These are 37.5%. Yeah, but as I said, we need to do this again because we first need to recode this variable. So let's go back to the data set and click on transform. Recode in this case, let's recode in the same variable. So we will override our variable work, and we want to override, let's first put our variable work here into the variable window, then click on old and new values, and here we can now, yes should become, or ja should become yes. We need to add that so that it is here in this window, and the second variable is 9 should become no, and we also need to add that. So we can click on continue and OK. And now let's again create our cross table. So analyze descriptive statistics, cross tables. Here we still have our variables and all the options. Yeah, here statistics, we have the chi-square test and the phi and Kramer V. In the cells, we still have the observed values and the percentage in the row. And we have here our grouped bar charts. Let's click on OK. Okay, and here now you see we only have no's and yes and ja and nein. We don't have ja and nein, the German expressions anymore. So now you can see at Alba we have 100% of the students working, in your class 37. Psychology we have about 48.7% of working students and so on. So let's see, all in all, are these variables independent or dependent? And obviously the differences are significant. So the probability that a student works depends on the class he's a member of. Here we also have the Kramer V, and I think the Kramer V is measure how strong the relationship between class and work is, and it is a little bit like the correlation coefficient. So 0 to 0.3 is a weak correlation, 0.3 to 0.6 is a middle correlation, or a middle strong relationship, and higher than 0.6 that would be a strong relationship. So it's a middle strong relationship, you can say. Here you have the bar charts for all the classes. You can also add the double click. We open the editor for the chart, and we can add the numbers into the bars. Okay, and close. So that's the cross table. So we can refute the null hypothesis and confirm our research hypothesis. The proportion of working students indeed is different in the examined classes. So if we have the combination nominal scaled and ordinal scaled data, an example would be the educational level depends on skin color or race. Educational level is ordinal scaled because you can rank the data again. Yeah, and you would also have to create a cross table and to apply the chi-square test. So if your research hypothesis is the educational level depends on skin color or race. If you have the combination 2 times ordinal scale data, then obviously you can also create a cross table, but you can also calculate a correlation coefficient. Yeah, and that is the correlation coefficient of Spearman. We have 2 main correlation coefficients that are Spearman and Pearson. Yeah, Pearson is for if we have 2 times interval scale data, then we calculate the correlation coefficient of Pearson. And if we have 1 time ordinal and 1 time interval scale data, then we also need to calculate the correlation coefficient according to Spearman. So let's do that. Let's have a look into our data set. But in our data set, we don't have ordinal scaled data, I think. but we can create ordinal scaled data because, as I said, if you have grouped data, so data in classes, then you would always consider it as being ordinal scaled. So we can, for example, group our data of the left-right spectrum. We have here the question was on a scale from 1 very left to 10 very right. What are your political attitudes? And let's say now we want to group this data, the scale from 1 to 10, and we want to group it so that we have the 1, 2, 3, 4 as left, the 5 and the 6 as the center, and the 7, 8, 9, 10 as right or conservative. So we need first to group our data. Therefore, we click on transform again. Recode, we now create a new variable, so we recode into another variable. And so we first need to explain which variable do we want to recode. That was the left-right spectrum. Here is it. We put it into the window. Now what should be the name of the new variable? It should be left-right group. Yeah, so we have to click on change, don't forget that, so that we have here the whole information for SPSS. Now we have to click onto old and new values again, and here we have to explain how we want to change it. So we can, for example, use this option, the smallest value, which is on a scale from 1 to 10 is a 1, up to the value of 4, and that should be our new value 1 for left. Yeah. So we need to add that. Then our value from 7 up to the highest value, yeah, should be our 3. That is our right ones. And then the rest, all other values, should be the 2. These are those in the center. Okay, so now if we have a look at the end of our data set, here you see our new variable, light left right grouped. Yeah. So we can get rid of the zeros. If we go to the variable view, here we have our new variable, and we can here go down to 0 places after the comma. So let's first have a look. Let's create a frequency table so that we see how many left, right, and center students we have in this group. We click on Analyze Descriptive Statistics Frequencies. Analyze Descriptive Statistics Frequencies. And here we can take our new variable or grouped data, and let's also create a bar chart with the percentages. We don't need statistics. We cannot calculate here. We could calculate the median and the mode, but not the average, not the mean. Also not the standard deviation, because we have ordinal scale data here. So let's just click on OK and OK. So here we have our frequency table. First the absolute frequencies, then the relative frequencies in percentage. So 60% or 72% are on the left side. Yeah, maybe I've created the left side too big, 1 to 4 is a lot. So we have 26.5% in the center and 1.2% on the right side in this case. Yeah. So this is now can be considered as being ordinal scaled. And now if we want, for example, calculate the correlation coefficient between political attitudes and let's say how satisfied they are with their life. So satisfied with their life is still a scale from 1 to 10, is interval scaled. Political attitudes, in this case with our new variable, is ordinal scaled. So we would have to apply the correlation coefficient of person. So let's do that. We click on Analyze. Here we have correlation, and we use the bivariate correlation here. Then we need to put our two variables into this window on the right side. So satisfied with life, and the new variable left, right grouped. And here we have the different correlation coefficient. In this case, we would need to apply the Spearman because one of the two variables is, as I said, ordinal scaled. Yeah? If we would have here two times variables which are interval scaled, then we could apply the person correlation coefficient. So let's just go. Let's have a look at the options. We don't need anything here. We also don't need bootstrap. So we just need here to say if it's a one-sided or two-sided test. In our case, yeah, I don't. So our hypothesis would be there is a difference between political attitudes and the satisfaction with life. So that would be a two-sided hypothesis. If your hypothesis would be conservative students are happier than left students, then that would be a one-sided hypothesis. So let's just click on OK. And here we have the correlation coefficient. So obviously it's not very high, 0.04. So that's close to no correlation. And obviously here in the second line, this correlation is not significant. Yeah? So there is no significant correlation between the political attitudes and being happy in life. So our alternative hypothesis, we could not prove our alternative hypothesis that there would be a difference. One more remark. Usually you would never, if you have the correct values for left, right, here the interval scale data, you would always use the interval scale data and then calculate the person correlation coefficient. You would never reduce it to ordinal scale data because obviously there you lose a lot of information. I just did it to have an example how to calculate the person correlation coefficient. Okay, now let's have a look at the combination nominal and interval scaled data. And therefore we can, if the interval scale data have not too much different values, then we could also create a cross table. But if we have too much different values, then that would be a very big cross table, and that would be more confusing than helping to create information from the data. So here I have two examples. On average, men have a higher income than women, or cars from US have more horsepower than cars from Germany. Yeah. So if you don't, you can create a cross table, but that does not always make sense. But what you can do here is you can compare the means. And therefore, when you compare the means to see if the difference is really significant, there are two different possibilities. First, you can apply the t-test. Yeah, that is if you compare just two groups, like men and women. Or if you have more than two groups, then you need to apply the ANOVA. And the ANOVA is a little bit more complicated than the t-test. So let's first apply the t-test and then the ANOVA. Let's have a look at our data set. So let's examine the hypothesis women have a lower interest in statistics than men. Yeah, we have here gender and interest in statistics, and our hypothesis is women have a lower interest in statistics than men. So there we can obviously apply the t-test. So we go and analyze, compare the means, and then we click on t-test. Here we have different t-tests. And important here we need to take the t-test for independent samples. T-test bei unabhängigen Stichproben is a German expression. T-test for independent samples. because we split our whole sample into two samples, one for the males and one for the females, and these two samples are independent from each other. A dependent sample would be if we compare two variables with the same persons. Yeah, for example, if we have the hypothesis those who have a higher interest in statistics already know more about statistics. Yeah, there we would have to apply the t-test for dependent samples. And then we also have the t-test for one sample. That would be if, for example, you know that the general interest for statistics in the whole population is at 5.6, and you want to compare the whole sample to this value of 5.6. That would be the t-test for one sample. But mostly we apply the t-test for independent samples because very often we want to compare two groups or more groups of our sample. If we have more than two groups, then here we have the variance analysis. So let's click on t-test for independent samples. So we first need the variable that groups our sample into two samples, and that is gender. Yeah. And here we need now to define the two groups. The first group would be male, and the second group then would be female. Continue. We have here the two groups. Let's click on options. We don't need anything here. So we need to take our test variable now we need here. So this is our grouping variable, gender, and our test variable is the interest in statistics. So we take interest in statistics here and click on OK. So here you have the average. So women's interest is at 5.16, males at 6.26 on a scale from 1 to 10. So the male's interest in this sample is higher. Now again, SPSS compares these observed values to the values that we would expect if the average is the same, yeah, between males and females, and then he calculates the significance. And for the t-test, it is important that for the t-test, one important prerequisite is that we have the same variances in both groups. So the same variance among males and among females. And we test that with the F-test, yeah, the Levene test of variance equality. So this is the F value, that is not so important. Now here we have the significant, and we see it is not significant. So that means the null hypothesis of the Levene test is that there are no differences in the variance. And obviously we cannot refute this null hypothesis, so we can assume that we have the same variance in both groups, so we can interpret our t-value here. And here we see it's exactly 0.05. So it's just significant. Yeah. If we wouldn't have had here the same variances, then we would have to interpret the second line. There we apply the Welch t-test, I think. I'm not exactly sure, but here we have another significant, and then that would not be, the difference would not be significant. But as I said, in our case, here we have, it's not the significant, so we cannot refute the null hypothesis that the variances are the same. So we can assume that the variances are the same, and therefore we have to interpret the first line. And there it's just significance, the difference between men and women. Okay, so we can refute the null hypothesis that there is no difference between men and women according to the interest in statistics, and assume that there is a difference. So maybe you should pause the video here for a moment and create also a cross table for these two variables, gender and interest in statistics, to see the difference. And we will continue with the ANOVA. As I said, we need the ANOVA when we compare the means of more than two groups. So for example, in our data set, let's say we want to compare how satisfied the different classes are with their studies. So we have the variable how satisfied are you with the studies on a scale from 1 very unhappy to 10 very happy. And to apply the ANOVA, we need to go on analyze to compare the means. And here we have the ANOVA. So the null hypothesis of the ANOVA is always the same, is that there are no differences between the classes or between whichever groups. And the alternative hypothesis is that there is at least a difference between two classes, a significant difference. Yeah. So let's click on analysis of variance. Now you see, I don't know exactly why SPSS is doing this. We don't have the classes here because we only have numerical data here. So therefore, we first need to transform classes into a new variable where we have for every class a certain number. So we click on transform, recode into another variable. Now we take class, and the new variable's name should be class n for class in numbers. Click on change. Don't forget to click on change. And here old and new values. So here, let's say we want to have social work 1 should be the 1 at, then social work 2, soziale Arbeit 2 should be the 2, psychology 1 should be the 3, Alba should be the 4, don't forget the add, and ESM is the last of the 5 classes, should be the 5. Add and continue. Okay. So now if you click into the variable view, you see we have a new data class in numbers, and in the data view you also see it at the end of the data set. Here we have our new variable class in numbers. Why don't we have number here? Did I forget a certain class? Obviously I've done something wrong here. Some values are missing, and I think these are the values from social work 1. So let's have a look again into our transformed data. Old and new value, and here's a mistake. So let's do it new. Soz arp 1 should get the value 1. Here I need to add. Continue and OK. Let's have a look. Now we have here also for social work 1 for the class we have all the ones here. So in the variable view we can take out the places after the 0. Now we have exactly the numbers, and now we can apply the ANOVA. We can compare the classes according to happiness with their life, happiness with their studies, and so on. So, but our hypothesis now was that there are differences between the classes according to their happiness with their studies. So we want to analyze that. We go on analyze, compare the averages, and one factor variance analysis. And here we need our new variable. Here we have class in numbers. Oh no, that is not correct. It is a factor variable, because this variable again parts our sample into different samples for every class and calculates then for every class how happy or how satisfied they are with their studies. So we don't need contraster, I think, no. What we need here is a post hoc test, because as what I already said is that the ANOVA only tests if there are any differences, but we don't know which differences would be significant between which class. So therefore we need to apply the post hoc test, and the Bonferroni is a good test that we can. These are all different tests. I even don't know all the tests. I know the Shefley and also the Tukey test, the Duncan test, but I don't know the other ones. But with Bonferroni, you can always take Bonferroni. So we click on continue, and then here we have options. Here you also want to have the descriptive statistics, so at least averages. We want to have the test for homogeneity of variances, because as with the t-test, also for the ANOVA, we have the prerequisite that the variances are the same for all classes, and if they are not the same, then we need to apply the Welch ANOVA. We also want to have a diagram of the means, and that's okay, so we click on continue. So now let's interpret the output. So first we have the 5 classes: social work 1, social work 2, psychology 1, ALBA and ESM. Then we have the averages. And here the happiest class are the psychology class, I think, with 7.8. Class on the second place with 7.3. So here we have the test for homogeneity of the variances. We have here the significance. Yeah. Again, the null hypothesis is we have the same variances. So we cannot refute the null hypothesis that we have the same variances. So we can assume that we have the same variances. Then we have the ANOVA here. The ANOVA, the null hypothesis of the ANOVA, as I said, is the null hypothesis. There are no differences, yeah, between the classes and how happy they are with their studies. But this null hypothesis we can refute, because here we have a significant value, and we can assume the alternative hypothesis. Then there are differences between the classes. Yeah. Here we have the Welch test is also significant. We would have to interpret this value if we had a significant value here. So if the variances were not the same, then we could not interpret the ANOVA. We would have to interpret the Welch test. And now let's have a look at the post hoc test. Here we have the post hoc test. And the post hoc test shows us exactly which differences between which classes are significant. It is always the values with a little star here on the top. So here we have the first class, which was social work 1, and the difference to the second class is minus 0.52, and that is not significant. But the difference to the third class, psychology 1, is minus 1.79, and that difference is significant. So the psychologists are significantly happier with their studies than the social workers, number 1. We don't have any more significant value. Here we have significant value. Yeah, that is the same. This is 3. This is the class psychology 1. And this is the difference to social work 1, our first group. Yeah, and the difference is 1.7, and it's also significant. Here we have another significant difference, the difference between class 3 and 4. 4 was Alba, is also significant. Yeah. Then here we have another significant difference. So the difference between class 4, Alba, oh no, it's the same, and Psychology 1. And here, this is your class, and the differences to the other class are not significant. Yeah, so there are differences here, for example, to Alba, a difference of 2.1, but it is not significant. And I think that is because we only had 8 students in Alba and 8 students in your class. As I already said, if you have small samples, then even you need to have a very big difference to be significant. For bigger classes, smaller differences become significant. Okay, and here again we have a diagram for the averages of the social worker 1, social worker 2, psychology, Alba, and your class. But the only differences that are significant are those between psychology and social work 1 and psychology and Alba. Okay, so these were the main procedures we had so far. I hope this video is helpful for you to understand when to apply which procedure. And yeah, see you on Wednesday.